Hello students, we are solving ISI M.MATH subjective question 2018. This is in this we will be solving question number 6, which is a probability based question. So let's see. Suppose that an urn contains a red ball and a blue ball. A ball is drawn at a random and of the same color is added to the urn along with the one that was drawn. Okay, the process is repeated infinite times. Okay, let x denote the random variable that takes the value n if the first n-1 draw yields red balls and nth draw yields blue ball. So why we have to do in the first part, if n greater than or equal to 1, so find probability of x greater than n. So we use this, so induction here of n, so let n equal to 1. So the event x greater than 1, if this is an event, means that the probability that the first draw yields a red ball is probability of x greater than 1 is half. So assume that the event now x greater than n, okay, happens. So the first n draws yielded red balls, and before the n plus 1 is draw, before this there are n plus 1 balls and 1 blue balls in the urn, n plus 1 red and 1 blue. So the probability to draw the red ball is becoming, red is n plus 1 and this is n plus 1 plus 1. So here probability of x greater than n plus 1 is probability of x greater than n, probability of x greater than n plus 1 given x greater than n. So that is n plus 1, n plus 2, probability of x greater than n. So obviously if x greater than n equal to 1 by n plus 1, then obviously probability of x greater than n plus 1 is 1 by n plus 2. Now for n equal to 1, the equality, if we see x greater than n is 1 by n plus 1, so this becomes true. So for n greater than equal to 1, which is the question, so probability of x greater than n, the value will be 1 by n plus 1. Now let's take a look into the second part. So that the probability of a blue ball being chosen is eventually 1. Okay. So if the blue ball is never chosen, then x greater than n, this part for all n. So denote capital N with the event when a blue ball is never chosen, not blue. So probability of n less than equal to probability of x greater than n equal to 1 by n plus 1, that tends to 0 if n tends to infinity. So obviously probability of n is equal to 0. So that's the second part done. Now coming to the third part. Probability of find the expected value of x. So n is greater than equal to 1. So probability of x equal to n will be probability of x greater than n minus 1. So then you can reach to this, okay, minus probability of x greater than n. So the space between these two. So that is 1 by n minus 1 by n plus 1 from part 2. So that is 1 by n into n plus 1. So expectation of x bar is summation of n probability of x equal to n. So that is summation of 1 by n plus 1, n equal to 1 to infinity. So 1 by this part, so possibilities will be, this will be keep on going, and that's the part. Next question. Okay, so this is a real analysis question. A real number said to have a limit point on the set is proper subset of R if every neighborhood of x0 contain the point S other than x0. So consider the set S0 this thing, so that S contains infinitely many limit points of S. So in this case we can see that 1 by n if we take, that is 1 by 2n plus 1 by 2n we can write. So that is belong to S, so its epsilon is greater than 0, so an m is greater than 1 by epsilon. So 1 by n, 1 by n plus 1 by m, that is 1 by n plus epsilon, so you can replacing m with this. So every neighborhood of 1 by n actually contains a point from S which is distinct from 1 by n. So each point of 1 by n is a limit point of S, and that is belong to set S. So now if m greater than 2 by epsilon, so then 1 by n plus 1 by m is a point of S in the neighborhood of 0. Now 0 is the limit point of S. So we have proved the first part now, that 0 union 1 by n, m greater than equal to n, are the limit points of S. Now going to the second part of it. So in the second part they have asked, show that S is compact subset in R. So S is bounded, so it remains to prove that S is closed. Okay, suppose that S is this, so every neighborhood of X contains Y belongs to S. Now if X does not belong to S and Y is not equal to X, then X is a limit point of S. Okay, so since we assume X does not belong to S in this part, so it follows that X is positive for every value of k greater than equal to 1. So if we find a point 1 by mk plus 1 by nk, which gives you this thing, such that one by k. So in both the sequences mk k greater than equal to 1 and nk also k greater than equal to 1, so these two are bounded. So there exist values from m comma n which is greater than equal to 1. So such that mk equal to m we can take, nk equal to n we can take, and infinitely many values of k. But again x is, we have taken already 1 by n which is belongs to S, so which is not the case. So hence we can assume here n of k greater than equal to 1 is unbounded. So now let n of k j greater than equal to 1 be a subspace such that this limiting value, limit j tends to infinity, n k of j is equal to infinity. So if the sequence of mk is bounded, so there exists m greater than equal to 1 such that mkj also equal to m. So obviously from this particular structure, if we take x equal to 1 by m which belongs to S, so the sequence this mkj j greater than equal to 1 is also bounded. So we can pass to the another sequence mkj j to the power j actually, where j greater than equal to 1, so that converges to plus infinity. So we have x equal to 0. So in case x belongs to S, S is compact. Next part, C. In C they say find all limit points of S. So if we solve the first two parts, and the limit points of S are this, and all the values of n where n greater than equal to 1. That's it.